got Russ Fein with us right now. We're going to just start off real softball, get us rolling. Just tell our audience who you are, what you do, and your credentials around quantum computing.
Great. Yeah, my name is Russ Fein. I'm a venture investor. I've been affiliated with a firm called Corporate Fuel Partners for about 20 years. We've made a series of different technology investments, including one in the quantum area. Before we made that investment, I had been on a personal deep dive. I'd always been quantum curious, but I was not a formally trained physicist. I just was sort of a hobbyist, would read about relativity and string theory and quantum mechanics, just sort of out of curiosity. And one day I read an article about quantum computing early in the pandemic, so about 5 years ago, and I was just gobsmacked. I'd lived through the PC age and the dot-com age and sort of missed those from an investment perspective, and I thought, this is a generational wealth creating opportunity, and it's fascinating, and I don't want to miss it. I want to learn everything I can. And with the internet these days, there's so many resources and a lot of free resources, and so I went on a sort of a personal odyssey trying to learn, read everything, consume everything I could, and it was good timing. I had done a lot through LinkedIn, which turns out to be a good mechanism for networking in this field in particular. And so I would start posting about quantum and developed a following of my blog around quantum, and mostly I did the blog to teach myself. They say if you want to learn about something, you should teach it. And I thought if I could explain this in a way that my family and my friends understand, that I must really understand it. And then I was sort of looking for a quantum opportunity and stumbled on one. I met the CEO of Vescent Technologies about 1.5 years ago, and we hit it off, and one thing led to another, and I led an investment round last year.
Awesome. Based on your kind of, if you understand something, you could teach it to that point, what is your kind of go-to example of explaining quantum computing to somebody?
Well, the thing, so quantum is very intimidating, and partly because quantum is real. Quantum physics, quantum mechanics are real things, but we have a hard time visualizing them because they don't occur on our scale. Quantum is what happens when things are extremely small, like on the scale of electrons, photons, atoms, or extremely cold, or both. And at those extreme sizes and temperatures, quantum mechanics happens. And it's not intuitive, but it enables interesting things like superposition and entanglement. And you don't have to understand what those things are, but to know that they are understood by people. They can be broken down into mathematics. It's complex mathematics, but plenty of people understand it. And so by manipulating and using the atoms or the electrons or the photons to do things quantum, you can do pretty amazing things. And one of those is quantum computing. Early in my odyssey, I thought that was it. Everything's quantum computing, but it turns out that the same underlying principles that make quantum computers powerful are good for other things, like sensing and networking and timing. And so quantum really affects a lot of up-and-coming cutting technologies, including, of course, quantum computing.
And we touched on, obviously, institutions and even countries putting money into this, a lot of money. And I'm curious, obviously, the United States has sort of joined in on that as well.
Yep.
It's specifically in Colorado. How beneficial do you think Colorado has been to the quantum ecosystem? And maybe in a specific sense, the Colorado ecosystem itself has been beneficial in terms of the collaborative aspects that have sort of been ingrained in the Colorado ecosystem itself.
Well, it is an interesting point, and I moved to Colorado about 2.5 years ago, and not for quantum. It turned out when I got here, I realized what a great career move that was. I came for personal reasons. The last 4 really sort of cutting edge Nobel Prizes in physics, happened within a few hundred yards of where we're sitting. And so there's a good, strong, embedded culture around physics and quantum physics in particular. That really helped. Governor Polis has been amazing. He sort of gets it. He's very bullish on quantum and has been amazingly supportive of quantum, both directly and indirectly. And so I think you have the pull of NIST, you have the pull of the universities and the physics programs, the Nobel legacies, the support of government. All that sort of synthesizes together to make this a great place.
And a little bit about your like kind of personal life. I remember we were talking about last time, like your college, somebody in your college dorm was, I'm maybe messing it up, as some sort of scientist in some sort of way,
Yeah.
and you would talk to him.
Yeah.
So like, how has that transformation been, being just like, oh, like I'm talking to my college friend, it's super cool and interesting, to now where you're making these huge investments and talking to all these crazy people about quantum science? Like, how is that kind of timeline going? Or like,
Well,
how's
that's a
it
good point.
been?
It was graduate school where
Mhm.
the guy across the dorm was a theoretical physicist.
Mhm.
We called him Lawrence of physics. He was brilliant and he was very patient and he explained relativity to me like 100 times. And I still don't quite get it, but
Yeah.
I got enough of a sense of it from him to be excited by it. But it was really theoretical. It was really more of like sitting around with your friends trying to talk about the meaning of life. It's just
Mhm.
another way to explain nature. I didn't really think about it from a commercial perspective, and I don't think, you know, the. It's interesting we talk about quantum, and most of the people in and around the Vescent world talk about this as quantum 2.0, because you had semiconductors and you had lasers, which are both principally quantum phenomena that spawn trillions of dollars of economic growth. And so that sometimes is referred to as quantum 1.0.
Mhm.
But now to take that even further and to apply these quantum mechanics for computing and sensing and these other new areas have tremendous commercial potential. And so it's amazing to see how it's come full circle from just sort of being a thing to talk about in the dorm room to now being a
Yeah.
multi-trillion-dollar potential economic upside.
Mhm.
Who knew? I'm curious, when you finally reached a specific point of understanding with the qubit, were there any similar moments regarding just quantum in general? And what, if any, ideas, processes are you still working to understand now?
I had a bit of an epiphany with the quantum computing, or somewhat after maybe a year or so of studying. I sort of had this epiphany of an extra dimension that's being used. And again, that's a little cerebral, sort of hard to visualize, but I had this aha moment when I realized how much more power and information can be in the same underlying bit if it has extra dimensions. You think about, again, I don't want to get too technical, but you think about a computer today and the amazing amount of commercial value computers have added to our society. It's it's a switch. It's an on or an off switch, and there's billions of them. They go on and off really fast, but that's all it is on or off. And there's only three rules. There's and, not, and or. And every computer program, when you sell your junk on eBay, there's just three rules and bits that are either on or off, and everything else follows from there. It's pretty phenomenal, the power of computing. Well, now imagine if you have more dimensions to work with and more operators. And so I had this sort of aha moment that extra dimensions and the extra operators could phenomenally increase the computing power with a quantum computer. And that was a really exciting moment. And I'm still pretty excited about it. And I think more and more people every day get excited about it. And every day the people making qubits and making quantum computers are improving them. And so we're not quite there yet. There's no useful quantum computer program that you can run. There's no chat GPT moment because nobody's created anything yet that can do something other than sort of play or toy sort of problems. But that's going to happen, and I think it's going to happen reasonably soon. And then a lot more people will be talking about it.
Awesome. Great.
And was there any concepts that you're like still kind of studying now or still trying to understand, like talking with a scientist at Vescent or anything, that you're like, I know what you're talking about, but I don't really know exactly what it is? Is there anything like that?
Vescent's not building quantum computers. They're selling components for quantum computing makers, which is pretty exciting, and they're enabling components, and so that's great for Vescent. But I'm still pretty fascinated by the quantum computing, and I'm still struggling a little bit. There's a thing called a block sphere, BLOH, I think it is, and it is a three-dimensional representation of basically a circle with north, south, east, west, and 360 degrees. It's like a sphere, and so you can use that to visualize various gates for quantum computing. And I thought I understood that, and I could picture the X and the Z and the Y axes and the gates spinning and turning to different. The first time I saw a Hadamard gate on a visualization of that, I was like, oh, now I understand it. So for a couple of years I thought I understood it, and then I realized, wait a minute, they're not actually spinning atoms, they're not spinning electrons. It's all kind of a mathematical construct. And so I'm still a little bit stuck on how that actually works in my brain. To sort of picture a gate is still a little bit challenging for me.
Let's imagine it's 2030. What does the quantum industry look like when/if things go right? If they don't go right, I imagine it doesn't really look as anything like it does today. But
I think it will go right. I think you can define what right is. I think we're very close to where a quantum computer is going to add value to a problem set. I don't think by 2030 you're going to have a quantum computer in isolation sort of doing stuff by itself. I think it's going to be integrated, certainly with classical computing and probably with AI. I think the fastest way that we're going to see useful use of quantum computers is going to be with AI. And I'm not an expert on AI, but I know enough to know that AI is probabilistic. When you have a large language model, you sort of give it a word, and then it gives you the next likely word, and it creates sentences and things based on probabilities of the next word. Quantum computers are probabilistic, so there's sort of, in my head, a natural kind of symbiosis between them. So I think that the early quantum computers are going to help supercharge the large language models in their learning. And then I think at the same time, because quantum computers are so complex and the algorithms are so challenging, that the AI is going to help write the quantum algorithms. So I see a lot of symbiosis between those two, which is, I think, pretty promising and pretty exciting. And I want to learn more about AI just so I can speak to that a little more professionally. But I think you're also going to have better weather forecasts, things that are sort of intractable and complex today. Quantum computing by 2030, I think, is going to start to add a little more capability. And, in terms of logistics, in terms of portfolio maximization, in terms of things like weather forecasts, I think that's where you're going to see advantages. And it may not be, sort of blowing away that, it's so much better, but if it's 10 or 20% better than there is today, that could be pretty meaningful.
That's still pretty good, yeah.
Final one.
Yep.
Most important thing you would want people to know about in quantum computing and the Colorado ecosystem?
Boy, that's a hard one. I think that quantum, we were talking a little bit about this on the way up, it's very intimidating, and so it scares off a lot of people. But I would encourage almost everybody to try to learn a little bit about it. I mentioned there's 50 people at Vescent. I don't know, maybe 20 of them have PhDs, but that means 30 don't. And we have all manner of people there. We have people that are assembling, that didn't graduate from college, that are assembling, $150,000 optical frequency combs, and they're flawless. They make them so that they are meeting these exacting specifications. And so some of the folks that are on the line building those machines maybe didn't think about quantum. They just thought, oh, this is an assembly job. I'm good with my hands. I want to do this. There's going to be a ton of jobs like that. So I would encourage everybody listening, if you haven't, poke around on the web. I've been writing a blog. Look up my blog. There's lots and lots and lots of sort of basic introductory, no science needed ways that you can sort of get some sense of what quantum is. If you're in college or thinking about college, take some classes in quantum and in computing, in both. And I think you'll be well prepared for whatever comes our way with quantum computing over the next any number of years.
And that's all we had today. Thank you so much for giving your time,
coming.
answering our questions. We really appreciate it, and we think this is really going to add to our whole project and our whole story on quantum computing. So
I'm glad you guys are doing it, and I look forward to seeing the finished product.